Hi, I'm Jennifer Braggin, Applications Engineering Manager for Entegris. Today I'm going to talk to you about the importance of filtration in spin-on glue materials. Most semiconductor manufacturers today are looking at innovative ways to combine different components on the same chip. That's kind of difficult in some applications to get them all on the same process. So what they're doing is pretty innovative. They're trying to build them vertically with 3D integration. In order to do this, you need to use new processes and new materials to combine these different layers and stack them on top of each other. In order to do that, temporary bonding materials are used to temporarily bond a wafer to a carrier to further process it. This wafer is then removed from the carrier and then can be processed and combined with other different components to build a brand new chip in a new package. The typical defects that you see in a temporary bonding process include bubbles, shark teeth, and scratches. Some of these are very common to everyday processing today in the semiconductor world. Scratches are often introduced from wafer handling, so those are hard to eliminate. But bubble defects are very easy to eliminate when you understand the process and how bubbles are formed. By utilizing filtration during the temporary bonding application, you can eliminate the bubbles and create a uniform surface. As long as the surface is uniform, the wafer can adhere to the temporary bonding material and to the wafer carrier and continue processing safely without creating stress points that might crack the wafer during processing. So in the study that we performed in collaboration with IMEC and Nanotech, we wanted to really understand and optimize the process of depositing the temporary bonding material and removing and reducing the number of defects that are passed along into the temporary bonding material. To perform this experiment, we utilized Brewer Science's HT1010 temporary bonding material. What you see in the image are the list of process conditions that we used to perform the basic experiment. The HT1010 material was deposited and dispensed using an Entegris Intelligent HV dispense system. The dispense system utilizes a unique two-stage dispense technology. This separates the dispense function from the filtration function. The end user can solely program the dispense function to focus on properties that are good for dispense, and separately focus on programming the filtration function for properties that are important for filtration. This allows the end user to really customize the program to have good dispense properties for uniformity, thickness, and material used, while also controlling the defectivity properties to ultimately reduce defects by really understanding the filtration process and tuning it to the filter being used. In this case, an Impact HV 1 micron UPE filter was used as the point-of-use filter to remove bubbles. The image you see is a comparison of 3 different wafers, which resulted from 3 different dispense techniques. In the first technique, you see a manual dispense. This is a dispense that's done through a syringe. What you can see is the non-uniformity in the image as well as bubble defects. In the second image, you see the use of a flushing shell with the Intelligent HV. A flushing shell is an empty shell that doesn't contain any membrane material. The ultimate use of a filter is using the membrane to stop a bubble. So our flushing shell has no membrane and therefore can't stop a bubble. What you see is that we've intentionally injected a bubble which has been deposited on the wafer. Therefore, the flushing shell is not protecting the wafer from bubbles, and this is a problem. However, in the third image, you can see the use of the Intelligent HV with a filter, with the 1 micron UPE filter. What you see is very uniform surface and absolutely no bubbles. The filter membrane was able to stop the bubbles that we intentionally introduced and prevent them from being introduced into the temporary bonding material that ultimately was coated on the wafer. To further analyze the effect of bubbles, we further processed 2 additional wafers that we would temporarily adhere to a carrier, polish through a polishing process, and then remove from the carrier to understand what happened to the wafer during the polish process. The first image you see is a wafer that was coated with the manual process. You see with the CD uniformity data that the wafer is not very uniform, or the temporary bonding material is not very uniform, and there are bubbles on the surface. The second image is with the Intelligent HV and filter installed. You see that the wafer surface is very uniform, and in addition, we've provided results for 6 other wafers to show the performance of the uniformity. So now that these wafers have been processed, the temporary bonding material has been applied, we then again attach them to a carrier surface, push them through a polishing process, and then remove them from the temporary bonded material to understand what happened during the polishing process. What you see in the image now is a result post-polishing. The manually coated wafer had areas of bubbles and non-uniformity, as noticed originally with the seed uniformity data. What you see now post-polish is the magnification of those defects. While this wafer was successful in being polished, those areas of non-uniformity were pervasive during the polish process. That means that this wafer wasn't uniformly polished because of those bubble defects. However, the wafer coated with the intelligent HV didn't have these defects to begin with, so you see that the surface is just as uniform as it was when it began. So in conclusion, reducing bubbles in the temporary bonding process is very important. It's very important for further processing and being able to stack these chips on top of one another. In order to reduce bubbles, there are many ways to go about it, but one important way is understanding how your dispense system can help in reducing bubbles. By adding a filter as a bubble trap, you're able to remove the bubbles in the process line and not have the bubbles be deposited on the wafer surface. Using the Entegris Intelligent HV system combined with an Impact HV filter can meet this need. Thank you.